So now we're going to go ahead and take a look at something called the congruence of integers. First, we're going to consider some phenomena that are cyclical in nature. Then we're going to use these examples to define what it means for integers to be congruent. And then we're going to use this definition to determine whether or not two given integers are congruent modulo some other integer. And this sounds a little bit vague now, but it'll be more precise when we get there. So the first thing that I want to look at is the example of days of the week. That's one of the things that you can think of as being in some sort of cycle, right? No matter what day of the week it is, in 7 days, it's going to be the exact same day again. So it moves in a cycle. So I'm going to use that to demonstrate something to you. So let's suppose that today is Thursday, and then the question is, what day is it going to be in 25 days? Now, we could just count out 25 days and see what day we end up on. We're going to try to find some more clever ways of handling that. So the first thing we're going to do is I want to find the closest Thursday to the day that is 25 days away. There is more than one Thursday between now and 25 days away. I want to find the closest one so I don't have to do any complicated arithmetic. So let's see when the Thursdays are going to happen. Well, the first Thursday that's going to happen besides today is going to be in 7 days. After that, the next Thursday after that is going to be in 14 days, then 21 days, and then 28 days. And notice that between 21 and 28, that's exactly where our 25 days is. All right, so what we're going to do now is we're going to note that, well, Thursday is in 21 days, 25 days is 4 days later. So instead of having to count 25 days, I just have to count 4 days. So let me see, we're on Thursday, Friday, Saturday, Sunday, and Monday. Right, so Monday is going to be happening in 25 days. Now, one thing you might want to notice is that 25, which is the 25 days in the future that we were trying to figure out, is equal to 7 times 3 plus 4. And if that looks familiar, that's exactly our quotient remainder stuff that we were doing in the last video. And each of those numbers in that quotient remainder equation have a significance, right? That 7 is the 7 days per week. Now, in the division problem, we're dividing 25 by 7, so we're dividing by 7. The 3 represents the number of weeks between now and the last Thursday before 25 days. That's our quotient, right? 25 days from today, that's what the 25 represents. That is, we're taking 7 and dividing that into 25. And then finally that 4, which is the one that actually helped us figure out that it was Monday, that is actually the remainder. Now, days of the week is not the only example of something that moves in a cycle. Let's think about time. So, for instance, right now it is 8 o'clock. What time will it be in 67 hours? And again, just like days of the week, time works in a cycle as well. Every 12 hours, it's going to be the same time as it was 12 hours ago. Now, I'm not worrying about AM and PM. That's a whole different situation. Right now, we're just figuring out time. We don't care whether it's the day or at night. So we're going to do the same strategy. Let's find the closest 8 o'clock that is closest to 67 hours away. So what do the 8 o'clocks look like? Well, the first 8 o'clock is going to happen in 12 hours. The next one in 24 hours, 36 hours, 48 hours, 60 hours, 72 hours. So that 67 is between the 60 and 72 hours. So what we're going to do is we're going to look at that. So I just said that. Whoopsies. So we're going to take that 8 o'clock in 60 hours, and then that 67 is just 7 hours later. So instead of having to add 67 hours to 8 o'clock, I just have to add 7. So let me see. Even that's not going to be trivial, right? Because it's 4 hours to get to 12 o'clock, and then 3 more hours to get to 3 o'clock. All right, we did it. So again, note that 67 is equal to 12 times 5 plus 7. That is another quotient remainder thing. Now notice with the 7, that is not our official remainder, because really we're taking 67 and dividing by 5. We're using a remainder that's not smaller than 5. So that's a naughty little remainder, isn't it? Well, anyway, we won't worry about that. But in any case, it's the same thing we had before. 12 hours in cycle, that's where the 12 comes from. And we're dividing by, we're not dividing by 12, are we? Yeah, we're dividing by 12, right? Yeah, there's 5 cycles around the clock that we're taking to get to that last 8 o'clock that comes before 67 hours. That's our quotient. 67 hours from now, that's what we're dividing by. We're dividing 12 into 67. And then finally, 7 hours past the previous 8 o'clock tells us, helped us figure out that we ended up at 3 o'clock. That's our remainder. And again, it's not really a proper remainder like we were doing back in the old days, but it's still a remainder. Still, it's a good remainder. Don't give it a hard time. All right, so let's see if we can notice some patterns in these two examples. So in the first one, what we were saying is that if we go into the future 25 days, you get the same day of the week as 4 days, right? Now, that only happens if you have 7 days per week, so that 7 is really important. If we lived in a world where we had like 9 days a week or 6 days a week or something like that, then maybe 25 days and 4 days wouldn't be the same day of the week. But because of the 7 days of the week, 25 and 4, that's the same day of the week. Now, that's 67 hours. That's the same time of day as in 7 hours. But of course, again, that depends on the 12 hours per cycle. If our clocks were set up for a different number of the cycle, that would be a different situation. So what we're going to do is so basically anything that has any kind of cyclical nature, whether it's a cycle is every 7 units or every 12 units or any 15 units, if we had something else that we were measuring, that can be measured in the same way. And we're going to describe this with something called congruence. All right. So let A, B, and N be integers, and suppose that N is a positive integer. And what we're going to do is I'm going to tell you what it means for, now the way we would read this is A is congruent to B mod N, or if you want to be fancy pants about it, A is congruent to B modulo N, right? And so I'm going to tell you what that means. The A, B, and N all play an important role here. So if you want to think of days in the week, we could think of it as A and B represent the same day of the week if a week has n days. Now, we live in a world where a week has 7 days, but in the world of congruence, a week can have any number of days. It could have 12 days, it could have 3 days, it can have 2 days, it can have any number of days. Or if you prefer to be a time person, A and B represent the same time of day when a cycle of the clock has n hours, right? And again, we live in a world where it cycles around 12 hours, but we could have any number of hours, and that could still work in this definition. All right, so I want to give you a little bit more precise definition of this so that we can do some computations. And I'm going to be using the days of the week model to understand this. If you like the hours better, that's fine. I'm not going to judge. So when is this congruence true? In other words, when is A congruent to B mod N? And I'm going to go ahead and look at a few situations where that's going to be true. Now, I'd like going for the simple first. So certainly, if A and B are literally the same number, that's literally going to describe the same day. A days in the future, B days in the future, they're the same number, they're going to be the same day of the week. But it could be that you could be a week off. So what does it mean to be a week off? Well, if I took B and added a week, right, a week is n days, right? So B plus n is going to be the same day except n days in the future. So if A is equal to B plus n, it's exactly the same situation as if A was equal to B. Same day of the week, different day literally, but the same day of the week. Of course, I could subtract a week, right? I can take B and subtract n days, still the same day of the week, still equal. And so that still describes what it means for A to be congruent to B mod n. We can add 2 weeks, right? If 2 weeks is 2 times n days, so we take B and add 2 times n days, that's like adding 2 weeks. We can subtract 2 weeks. We can add 3 weeks. We can subtract 3 weeks. And hopefully you see a pattern here, right? A congruent to B mod n is exactly the same as saying A equals B plus n times, I'm going to call it Q, where Q is the number of weeks separating A days and B days in the future. And I'm going to turn that around to call that A equals NQ plus B because that looks more like our quotient remainder. And again, in this situation, N is the number of days per week that we're dividing A by N in this situation. Q is the number of weeks separating A and B, right? That's our quotient when we do our division. A days from today, we're dividing A by N, right? So we're dividing N into A. The B days past today, that's going to be our remainder. All right, so here, let's do a couple of examples with some real numbers in there that aren't 7 or 12. Okay, so we have 7 is congruent to, I don't know, we're going to find a few numbers that 7 is congruent to modulo 9. Now, I'm going to stick with days of the week because I love days of the week for some reason. And in this situation, we have 9 days per week. Again, if you're a clock person, that's 9 hours for going around a cycle of the clock. So let's see. So let's go ahead and add a week to 7, right? That 7 plus 9 is 16. That tells us that 7 is congruent to 16 mod 9. Very nice. Let's subtract a week. 7 minus 9, that's going to be -2, right? 7 is congruent to -2. Now, if we're thinking days of the week, what that -2 means, that means -2 days in the past. So 7 days in the future is the same as 2 days in the past. And that makes sense. If I'm on Thursday, 7 days in the future is, well, actually, I shouldn't use Thursday because that's mod 7. But you get the idea. And we can do any number of weeks. If I add 3 weeks, let me see. 9 days per week. 3 weeks is 27 days. So 7 plus 27 is 34. And that means 7 is congruent to 34 mod 9. And we could do this forever if we wanted to. And if you do, go for it. I'm not going to stop you. And so here's a different kind of question. Now, the first question was, I have a number. What are some numbers that are congruent to it? Now, this other question is, I have 2 numbers. Are they congruent to each other? And, of course, I have to say modulo what? And so I have 10 is congruent to 29 modulo 3. Is that true? Now, remember, the 3 means that the mod 3 means we have 3 days in each week. Very short weeks. Hopefully, we have a long weekend. All right, so what I'm going to do is I'm going to take 10. I'm going to keep adding weeks and see if I ever hit 29. So we start with 10, right? Add a week, that's 3 days, that's to 13. Add another week to get to 16. Add another week, add another week, add another week, add another week, add another week. Oh, we missed 29, right? We skipped 29. That means 29 wasn't in one of the number of weeks from 10, which tells us that 10 and 29 are not congruent mod 3. Notice that slash in that 3 lines. That says they're not congruent. Kind of a bummer. All right. Well, that was kind of tedious. And you could imagine if I wanted like 10 and like 352, adding 3 one at a time could take me a long time and I could get really bored. So I'm going to show you an alternative method for doing this. So one of the ways of doing it is if I look at the number of days between 10 days and 29, if those two are congruent, if those literally represent the same day, they should have a whole number of weeks in between them. The way I can figure out how many weeks are in between them is figure out how many days. And that's just subtraction, right? So I take 29 minus 10. There are 19 days between 10 days and 29 days. And then the question is that 19 days a whole number of weeks? Well, guess what? It's not a multiple of 3, right? Because if you look at multiples of 3, 18 comes right before, 21 comes right after. What a bummer. That tells us that there is not a whole number of weeks between 29 and 10. And that tells us that they are not congruent mod 3. So this should give you enough to at least start with the activities. Let me see. The ones you're looking for are called Congruence of Integers. That's on the PDF file included with this video.